Hello, we are Group 10, and for our project, we made a solar oven.
So does our solar oven work? Basically, the way it works is that the UV lights of the sun that reflects off of the reflector, and once it does that, it hits our well, this is a cook pot that is right here, but we used a plastic cup. Observations and questions. Observation: the water will heat up a little from the sun's energy, and it will possibly boil over time. It is time consuming. There also doesn't seem to be a particular way to cook or heat food without relying on gas or electricity. And then our questions are: what sort of design shapes would work best? What insulating materials would best maintain the temperature if our oven ends up having an enclosed design? Will using a certain colors on certain parts of our oven cause more reflection of absorption of heat where necessary, resulting in better effectiveness? Will outside temperature factor into our oven's effectiveness, or will good sun exposure negate cooler outdoor temperatures?
Our hypothesis, the color of the inside solar oven allow with the use of a parabola to focus on the to focus and reflect the light to a focal point, and using certain material when constructing our solar oven or make our solar oven more efficient, effective and efficient. So that does color make a difference? Yes. Color plays an important role in heat absorptions. Due to the property of light and wavelength, dark color absorb a broad spectrum of a light wavelength and retain heat instead of reflecting it. As efficient light absorbs, they convert absorbed light energy into thermal energy, emitting heat. And white color reflects nearly all wavelengths of light, absorbing very little energy and emitting almost no heat. Therefore, they remain cooler since minimal thermal energy is produced.
So why do we use parabolic? So parabolic gather all the incoming wave and clean wave that is traveling around the horizon and reflect to a point called focal point. Focal point is where all the light meets upon the ray reflected of the parabolic surface. So in the picture, there's in on the upper picture, there's where all the reflected light meet. And we did not use the spherical mirror because shown in the down image, um, the focal point is all over the place because they are not a very good reflector and uh, reflected wave will not intersect with the same point. So for our parabola, we use the equation y is equal to 1 by 40 x squared so that it is big enough for solar oven to give out a good focal point. So all the wave will be focused on a point, and the water can be heated quickly. So our focal point was like 10 centimeter from the vertex of our pergola, and we place our pot at that distance so that the water will be heated quickly.
Uh, so what we used to test our oven, so we decided water would be good indicator of the solar oven's effectiveness due to the high specific heat of water. Water's specific heat is generally high compared to other substances, which means that it takes a significant amount of energy to raise its temperature. Its high specific heat allows water to regulate temperature fluctuation. This gave us a reliable temperature reading. Based on the equation, we calculated that our oven generated 16.6 is this kilo kilograms of heat energy. Our oven raised the temp of water by 33.6 degrees Celsius at its best.
So this was like the kind of basic construction of the oven. The picture on the left, we graphed a parabola and then we cut it out to use as like a stencil so we could cut out cardboard pieces with the same curvature of the parabola. The top right picture is kind of just our materials used, and the bottom right picture was the flattened piece of aluminum foil that was on top of a piece of like poster paper. It was kind of challenging to bend that aluminum foil once we stuck it on and not have it kind of like crinkle up. This was the final product. We were able to get the parabola in the box pretty smoothly. This is what we used on the right here to suspend the cup. And we measured the bottom of the cup was 10 centimeters from the vertex. This was the actual testing of the oven. On the left, you can see we have a little digital thermometer in the cup. We also wrapped the oven, the opening in plastic wrap so that the sun rays could enter, but the heat couldn't really escape. The middle picture and the one on the right, you can see we used a cup just covered with plastic wrap, kind of like a control, just to have something to compare our oven's results to. Also, if you see in the middle picture, the rod is going across kind of parallel to the vertex. And then on the right here, we switched the orientation like 90 degrees to see if it had any effect. This was at the end. If the picture on the right, if you compare it to the one earlier, the foil was very smooth, but after like repeated heating and I think moisture, it caused the foil to get all wrinkled. This is the data analysis section. If you can see, we did 5 trials. We're checking every 5 or 20 minutes. Trial 5 was kind of a cloudy day. Trial 4, we didn't use a control. And here are some graphs. Trial 1, 2, and 3. Basically the same graph, which means that the oven was pretty consistent. Trial 5 was kind of a cloudy day, so after a while it did get up to temperature and actually lost temp. On the 4th day, there was just not 4th day, but the trial, there was just no control to compare it to, but yeah, it still performed pretty much the same. And in conclusion, I think overall, we thought the oven performed pretty well and consistently in the various weather conditions. I was able to raise and maintain the water's temperature effectively. When it comes to improvements, we thought maybe to use a parabolic dish instead of a trough to really maximize like the reflection and the focus of the light. Maybe just like more precision and actually making the oven itself. And if we could use like a better reflective material that wouldn't get all wrinkled up like a solid piece of metal, that would probably work better. And here's our bibliography where we got our information. And that is it. Thank you.
I meant to say kilojoules, not kilograms.
Kilojoules. There we go.
There you go.
All right. Thank you.
Thank you.